All right, I just realized, guys, that you probably had questions on more of the homework problems. Let's look at number 37 on 4-2. Because that one was just a weird graph at the end. So the function is f of x equals 2x squared minus 5x minus 3 over x cubed minus 2x squared minus x plus 2. The top you have to factor to 2x plus 1 times x minus 3. And the bottom you can factor by grouping or synthetic division or whatever works. In the end, you should get x plus 1 times x minus 1 times x minus 2. Now, none of those factors are identical, so nothing cancels, and there's nothing with multiplicity. So that takes away some of the weird stuff that could happen, but still there's plenty of weird stuff on this graph. Let's identify the things that should be obvious to you. It should be obvious that there are three vertical asymptotes. One at x equals -1, one at x equals 1, and one at x equals 2. Those are the three values that are not in the domain. And we can quickly graph those. Like so. Then you've got your horizontal asymptote. Whoops. The horizontal asymptote. Notice the original function, the degree on the bottom is a cubic, a third degree, and on top you have a quadratic, second degree. When it's larger on the bottom, that means as x gets bigger, the y value approaches 0. So y equals 0 is our horizontal asymptote. Boom. Now let's think about our intercepts. The y-intercept is easiest to get from the unfactored form. Look right up there. If you put 0 in for x, the y value is going to be -3/2. So plot that. 0, -3/2 goes right about there. And the x-intercepts, it's easiest to look at the numerator of the factored version because you're asking what makes the fraction 0. X equals -1/2 would make the whole thing equal 0, and x equals 3 would make the whole thing equal 0. So we can plot those. There's one right there, and there's one right there. Then what you're going to do is figure out some other points on the graph. Now, you could use the fact that there are 5 factors in the original function. You can see those right up here. There's 5 of them, 2 on the top, 3 on the bottom. So it's kind of like a 5th degree. We can go ahead and make that number line I was talking about on the other one also. Let's do that. So the interesting points are at -1, -1/2, 1, 2, and 3. And you know that it equals 0 at -1/2 and 3. And it equals, at the other 3, you have vertical asymptotes, so the function's undefined. Every single one of these factors has multiplicity 1, so I know that the signs are going to change positive to negative on each one. You can test some points as well if you like, but I know it's going to alternate positive, negative. So if you look at the far left, from -∞ to -1, it says it's negative. I don't have any points over here. If we want one, go ahead and plug one in. If you plug in -2, you get something around there. Whatever. Because it's negative and because I have these asymptotes here, I know it's got to fit within the asymptotes. Now, from -1 to -1/2, it's positive, and then you hit that x-intercept. So it's got to go along this vertical asymptote here. It's going to go right through that intercept because it has multiplicity 1, and then you're going to have all these negative points up through x equals 1. If If you look back at our number line, between 1 and 2, we have a positive. There's no points in there. It'd be a really good idea to plug in 1.5 or something to see where it is. I think for this particular one, it's way up high. I don't know how high up it goes, but it's some piece up there. There you'd definitely want to plot a point to see kind of where it goes. Between 2 and 3, the graph has to be negative. Again, you have to follow the vertical asymptote, so it's got to look like this. X equals 3 is an x-intercept with multiplicity 1, so it's got to go through the graph. But now what? There's a horizontal asymptote. It has to get to the horizontal asymptote. My number line says that it has to be positive. It's got to come back down at some point and approach it. Do we know exactly where that relative maximum is? No. But you would need calculus to figure that out, or a graphing calculator. This picture is as good as we can get without it. And we're good to go. All right, I'm going to give you a little bit of notes here on more stuff to do in section 4.2. So go ahead and take these notes. Follow along with the video. Write down some notes in your notebook. We're going to use the function f of x equals x squared minus 1 over x cubed plus x squared minus 10x plus 8. That cubic on the bottom looks familiar. I think that same cubic showed up on your quiz last time. If you need to pause me at any time to write something down or think about something, go ahead and do that. That's just fine. But of course, you're going to factor first. So why don't you hit pause and factor the top and the bottom and then come back to me. You should have gotten x plus 1 times x minus 1 on top, and x minus 1, x plus 4, x minus 2 on the bottom. That denominator, you want to do a synthetic division or something to break it down, but you should be able to get that. Notice there's an x minus 1 on the top and the bottom. So our original function is actually equal to x plus 1 over x plus 4 times x minus 2, as long as x doesn't equal 1. X equals 1 does not give you a vertical asymptote. We crossed it off. It's not on there. The graph is going to be a lot like this function with one exception, and we'll get to that shortly. Let's bust out the grid. And you want to find all the information you can know. Vertical asymptotes, horizontal asymptote, x-intercept, y-intercept. Hit pause, try to find those, and come back to me. You should have gotten two vertical asymptotes, x equals -4 and x equals 2. One horizontal asymptote, y equals 0. The x-intercept is -1, 0, and the y-intercept is 0, -1/8. So go ahead and plot all that stuff on your graph. Vertical asymptote, horizontal asymptote, 0, -1/8, -1, 0. If you like the number line, you can make that approach too. The interesting points are anything that makes the numerator or the denominator 0. Those points are -4, -1, and 2. And we know that it's undefined at the two of those points, and it equals 0 at another one. And if you look carefully at the reduced function that's circled in green up there, each one of those three factors, the x plus 1, the x plus 4, the x minus 2, shows up once. So the positive and negatives are going to change every time. It's almost as if it were a cubic polynomial. The lead coefficient's positive, so we end positive, and everything's going to alternate positive and negative. Again, you can plug points in to check. I know that the only place where this graph crosses the horizontal asymptote is at -1, 0 right here. because that was the only x-intercept. So on the far right of the graph, I know it's got to be positive, because it says so here, and I know it has to fit in the asymptotes. The only choice is for the graph to look like this. It has to follow those asymptotes. It has to be positive. Plug in a point to check if you want. In fact, I think if you plug in 3, you get here, so I didn't draw it very well. Let me fix it. From negative infinity to negative 4, the graph is negative and also has to fit in those asymptotes. Again, you can plot a point if you like. In the middle, it starts positive and then goes negative, and it has to follow those vertical asymptotes. It has to go through the intercepts. So that would be the graph, except look what we have up here. We said x can't equal 1, and if you look at our picture, x does equal 1. It's on there. That's bad. Here's the new thing. When you cancel the x minus 1 from the top and the bottom, you actually make a hole in your graph. Let's see what would happen if we plug 1 in to the reduced function, the one that's circled right here in green. If you plug in 1, you get 2 on the top, and you get negative 5 on the bottom, so negative 2/5 would be the y value there. That's what would happen if you plugged in 1, but of course this right here says you can't plug in 1. So I'm going to erase this middle part and do it again. I've still got this point, I've still got this point. But at negative 1 comma negative 2/5, I have a hole. I'm going to put an open circle there. And everything else should be the same. It should still follow those asymptotes. But there's a hole in the graph. So moral of the story, if you cancel a factor from the numerator and the denominator, and that factor's gone completely, it's going to leave a hole in your graph. And this recording's done.